Hey, good evening, everybody. Welcome to Meteorology Lab. We're back again for another week. And yeah, we're starting to get some storms breaking out across the central and southern plains. And even down in Texas, there's the radar loop for the past 6 hours or so. And there we see storms firing up around the Sweetwater and Abilene area and also up around Childress. So that's what's happening around the U.S. this evening. And that brings us to the current chart. And I do apologize having to take a break yesterday. I'm not sure what it is about this time of year, and this happened last year also, but it seems like I get a lot more constraints on my time, and you know, I want to get in here and do this analysis and keep up on the journals and all that, but there's just so many other demands on my time, and I'm really kind of struggling with this. But as long as we can keep this going at least 5 nights a week for springtime, I think we'll be in good shape here. Here's what we're looking at this evening. A weak front up there through Kansas, and this is getting more typical of what we see this time of year. So that right there is a polar front, and if you want to use the old symbols, that would be a continental polar air mass up there. And out here across the central plains, we've got the maritime tropical air mass. And then out in West Texas, this is a mixing ratio plot, and these green lines here, these are dividing dry air from moist air. And we put that boundary on the moist side of that gradient right there. So that's the dry line. And out to the west is our continental tropical air. And that tends to overlie the tropical air. So we see it up at about 5,000 or 6,000 over Texas and Oklahoma there. And we refer to that as the EML. And that's an abbreviation you'll see in various papers. You don't see that continental tropical designation very much, but you do see EML a lot. So EML is basically what's over the top of this and also at the surface there in New Mexico and Arizona. And that is an air mass that forms due to contact with very hot desert terrain out in that region. And we can see that some of the moisture does extend into the deserts of Mexico. And we're going to see that sneaking northward over the next 2 months. And towards July, that'll be moving into Arizona and the Four Corners region. But that's going to be a ways off there. Let's do a little mesoanalysis here. This is the Texas map. And before I get too far, let me see how the sound checks out. I put on the headphones and made a few changes there, so hopefully it sounds a little bit better there. Looking at chat there, David Lumbert reporting Central Arkansas at 92. Jeff Krob lurking from work there in Maryland, waiting for the storms to come through. Ron Chalfant in Southern California with us, and Burl H, Fun with Tech. Adam Davis, been soggy the past couple of days in northwest Pennsylvania. Derek Seymour and Christian Flock, Yukon, Oklahoma, following the storms in that area. Willie Greenway there in Georgia. Carl Berghoff. Willie is impressed how the storms fire throughout the day. Excellent, and I appreciate the comments there. Michelle Curlin missed a night of the program. Well, we took our break on Saturday, and then I took another day off on Sunday, so you probably didn't miss very much. Ryan Toomey is drowning in South Florida, very heavy squally rain, and it seems like the tropics are really getting active this season, and we're going to look at that later. And believe it or not, I've got some ECMWF products, definitely very new, and we're going to be looking at that later. EML is the elevated mixed layer. Yeah, very good there. Andrew Hotchkiss. Ryan reporting tornadoes in Broward County, Palm Beach County. Broward County, that brings up memories of cops on TV there. They always do their program down in that area. Thomas Copeland, severe thunderstorms in Virginia. And audio good. Mr. Manlett, 70s in Rockford. Best weather PT, big storms tomorrow in the Northeast. Okay, let's go into the mesoanalysis and see what's going on here. Let me get my monitor back up here. So there's the Texas map, and what we do is we start out with the big picture. So we see southerly winds, and then out in New Mexico and West Texas we see some westerly winds, and then well up to the north we see some north winds right there. So that's the dominant synoptic scale pattern. Then working from that we can find where those different regimes come together. Now I'm drawing a line right here, but I'm looking at dew point. It's tempting to look at the winds and think, well, there's convergence between where these two come together, so we're going to put the dry line there. That's not how you work it. You have to really use the dew point temperatures. So going by that, that puts the dry line out in this area here, and possibly all the way out towards Childress like that, off to Caprock. So maybe even a little bit further west. So that appears to be the basic dry line position. And then we see these strong easterly winds there around Big Spring, and that's probably thunderstorm outflow. And maybe I can bring up the radar. Let me plot the radar data. Okay, so we're ingesting data from various websites here, and those should be coming up. And indeed, you can see the outflow right there, the fine lines, especially out to the west. And we're seeing that a little bit better in this area here because it's kicking up dust and bits of vegetation, insects over the irrigated cropland out in that region. A lot of cotton and watermelon out in that part of Texas. And so we see kind of a series of outflow boundaries there. And the dry dew points in that area with that easterly flow, that kind of clues us in that that's also outflow there. And then we'll take a look up in Kansas. There's definitely a lot going on up in that area. North winds and a little bit of an upslope flow pattern in this region, northeast Colorado there. The problem is that there's a strong northerly component to the flow, so that kind of cuts down a little bit on the available moisture, but just enough to get some storms going around Burlington. And I guess that would be, I don't know, I need a reference map. I don't know what station that is. The county south of Goodland and Colby. So we got our front on the way south, and let's look at some of the other charts here. Another way we can put this together is with the isobars and thickness. We're definitely generating a lot of cold air up there in Hudson Bay, so that machine is definitely going full steam there, except a lot of those air masses are moving more towards the Canadian Maritimes. So this looks like one of the cold fronts pushing out of Canada there. Looks like we have another front down in the southern plains. And anything else? Well, there's a gradient right there. But we have to look at the flow. This is a high pressure region right there. So we have northerly winds on the east side of that high. That means that that's going to be a cold front. And that probably connects back up into our Canadian system like that right there. Okay, and we've also got this thermal trough off the California coast. And very likely that's going to produce an upper level trough in that region. So likely that's going to be showing up there on the GFS and NAM. Here's the SPC mesoanalysis. We're going to be trying to use a little bit more of this. Now, one problem is we've got a lot of outflow boundaries out in West Texas. So that's going to have an impact on these fields. For example, if I plot the velocity tensor magnitude, remember we used that a lot for finding fronts. It doesn't work so well with this mesoscale data there. So it kind of degenerates into kind of a mishmash there. I think maybe we can pick out maybe a couple of the larger boundaries, maybe something like that right there. So this is from the rapid refresh, and it's actually doing a little bit better than I'd expected. But at first glance, I'm thinking the boundaries are probably doing something like that right there. And obviously where the moisture impinges on this boundary, that supports some of the biggest cells. So right there, and also earlier, these cells were on the south end of that boundary. And of course the surface, I'm sorry, the visible imagery, that's very spectacular. Let's take a look at that there. And I've got the full loop. So we'll just give this a second to load here. And very likely we're going to be able to see the western edge of these outflow boundaries in this cooler air, or not the cooler air, the drier air. It's very devoid of cloud material. And yeah, keep an eye on these storms right here. And yeah, right here. See that little fine line right there? That's a little cloud of dust out around the La Mesa area. So that's pushing eastward, and it's producing a few elevated cells out in that region. Very high base cells there. Yeah, that stuff there, that's pretty much mostly out to cumulus. The big cells, though, those are moving into western Oklahoma there. You can see some very neat gravity wave structure. But I don't think these are actually very severe. Let's take a look at the watches and warnings. I think SPC will give that information to us. Yeah, there's the severe watches. No tornado watches in effect. And let's check out the storm reports. Looks like one tornado report. Looks like around Wellington. Let's see if we can bring that up there, find out where that tornado report was. Cowley, Arkansas City, and that was around 6:30 p.m. this evening. And no data. So probably a law enforcement report or something like that there. We also have had some hail reports there, a little bit of a cluster there in Kansas, and a few spotty wind reports up and down the Caprock into the Permian Basin there. Or actually, no, that's the Permian Basin. This would be the Concho Valley, out around San Angelo there. Okay, what else to look at? Let's see. I know we have to shift gears a little bit. I'm trying to figure out which product to go into next. I guess we can take a look at some of the severe parameters, maybe surface-based CAPE. There's a lot of heating, so this is a very good day to use surface-based CAPE. We can compare and contrast that with mixed layer CAPE, and we can see the values are up anywhere from 2,000 to 4,000. Some pretty good instability there in Oklahoma. We'll take a look at the shear parameters. Let's take a look at bulk shear, 0 through 1 kilometer. So we're looking at about 10 to 20 knots, and very likely this is being distorted a little bit by some of that outflow. So these elevated values may not be representative. However, they've got a little panel here that I believe it lets you go back, so you can kind of get a look at the environment before storms developed. And it looks like about 4 hours ago, most of the values were kind of on the low side. And these right here in Kansas, it looks like those are clustered around the existing cells, so that may be a little bit of convective feedback there. Overall, the wind environment looks pretty weak. Storm relative helicity 0 through 1 kilometer. That also looks to be pretty low. Again, it looks like we're getting some distortion there from the existing storms. But about 4 hours ago, let's see if I can get that to pause there. Yeah, there we go. Just kind of a very weak band there of 50 storm relative helicity values up along the Kansas-Oklahoma border. So we'll analyze that in a little bit more depth there with the high resolution rapid refresh. What else to look at? Let's see, what else? Yeah, let's look at the deep layer bulk shear. For that, we can go to surface through 6 kilometers. And we can see that the stronger shear is well up to the north. 50 knots up in that region, but it drops rapidly to the south as you go into Oklahoma and Texas. So that right there is going to be a major impediment to storm organization. And that's the reason we're not seeing a whole lot of severe in this region here, in spite of the high instability. All right, let's actually look at the upper data. Let's go to 250 millibars. Here's the charts for this morning. A very thin jet running from Four Corners up to the Dakotas. I can see some slightly higher values there in Texas, and that's probably a little bit of subtropical jet. Subtropical jets, they love that anticyclonic flow. They tend to develop in these ridges like you see right there. And typically as we get deep troughs moving into the plains, the subtropical jet will tend to build towards the north. The polar front jet will tend to build toward the south, and they'll kind of converge. And then you'll get that little diffluent pattern that we often see there. So not much help from aloft. There probably is some shear because the 0 through 6 kilometer layer doesn't quite reach up to the subtropical jet, but there could be enough, just enough shear in the environment to allow for a little bit of organization there. 700 millibars, let's go to that. Looks like we've had a little bit of weakening of the cap. Instead of 13 to 14, we're looking at 10s and 11s. So the thermal ridge, we can paint that out with the 11C isotherm. And that's about how it looks right there. So very warm conditions around Lubbock and Amarillo as we would expect. And then we have the spot of 12. And that's probably indicating maybe we had a little bit of ridging working on that area right there in Missouri. 850 millibars. This is 5,000 feet. We look at the moisture field. And I'm looking mostly at the dew points in the lower left. 14 there at Midland, 15 at Del Rio. So we're starting to develop kind of a classic moisture tongue there. There's the 12C isodrosotherm. 14 would be about like that right there. And how does the low-level jet look? Looks kind of on the weak side, 25 to 30 knots, and we would probably paint that about like that right there. So that's the weak low-level jet, and that's helping to bring some moisture northward, and maybe helping a little bit with the low-level shear there, just a little bit. And that brings us to the soundings. Let's check those out. Fort Worth. Do we have a Fort Worth sounding? No, we do not. But that's fine. We'll look at the morning sounding. Okay, so this is the 12Z sounding there at Fort Worth. Thanks to University of Wyoming for this information. And we do see that the capping is in place. It's a little bit weaker, but it's definitely there. The moisture is on the thin side, only looking at about maybe 60 millibars of moisture. That's about maybe 2,000 feet, 1,500 to 2,000 feet of moisture. However, assuming that we get a good rich parcel, 64-degree dew point, let's do a test lift. There's the moisture. And we'll pick a temperature, maybe go with the afternoon highs. Let's pick 90 degrees. That's going to be right there. I'll do that in red. So there's our lift up to the LCL. The LCL is looking like it's up at about 2,000 meters, which is on the high side. And then we condense and continue up the moist adiabat. So we definitely got some cape there. And maybe enough buoyancy to clear that cap. But the problem is that this is an overly optimistic moisture layer. There's a lot of dry air right above 2,000 feet that's going to get mixed into the parcels during the afternoon there. So realistically, we've probably got a moisture profile about like that. So let's try lifting that once again. There's our lifted parcel, just a little bit of capping. That probably looks a little bit more representative of what we have with these storms. But yeah, look at this. We don't really pick up that buoyancy. The buoyancy is the bottom of the, or I'm sorry, the buoyancy starts at the bottom of this cape area, and you can see that that's up at about 12,000 feet. So that's unusually high for this time of year. So a few problems going on with the soundings. Let's take a look up at Norman. This is how I looked at Norman this morning. And we can see that the moisture starts out about a 67 dew point, 62 right off the surface, and then tapers down to about 51 up at about 6,000 feet there. So dry air right off the surface there. So you got to factor that in as you're looking at forecast soundings. And they do have a fair bit of capping up there in Norman. So let's we can see that we started out with 67-degree dew points this morning. Let's see what happened during the day. Because as you mix some of that dry air down, you tend to see the dew points fall off during the day. And it appears that they've kind of held steady at about 68 there at Norman. And that indicates maybe a combination of evapotranspiration plus advection from the south. So one thing kind of offsetting the other. All right, so we can probably adjust the sounding upward a little bit and make our parcels a little bit more buoyant. Fort Worth, about 66 in that area. It looks like maybe about 68 for the parcels around Abilene. So let me bring that up. So you can see that we started out at about 69 there at Fort Worth, and we kind of held on to the moisture. So I'd probably go with maybe a mixed layer, something like that. And I think that's probably the most representative lift right there. So that's kind of how we go about working the Scutee. Just kind of a quick and dirty overview. What else is going on? Well, weak winds. A lot of mid-level wind weakness there. You have to really get up above 35,000 to pick up the stronger wind. And let's check out the hodograph. University of Wyoming does give us hodographs. But you got to keep in mind that these scales are in meters per second. So you have to double this to get knots. I don't think we've ever really done these hodographs from University of Wyoming. If we did, it was probably a long time ago. So what we're looking at here is the radiosonde launch from Norman this morning. And this is a plot of the wind speed and direction with height, starting out here. And the end of the launch is over here. At that point, the balloon was, I guess they probably terminate that at the tropopause on this diagram. So that's going to be about 45,000 feet. So what this has shown us is that for the surface plot, the winds were out of the south, and appears they were pretty gusty there. And the winds continued to be out of the south-southwest, very strong, and then you can see that the winds died off up about 5,000 feet, and they become a little more southwesterly at about 20 knots. And then we get the directional turning up at about 10,000 feet. See that 700? That's 700 millibars. That's about 10,000 feet right there. They don't plot the dots, but I would assume it's right around here. And then up at about 600 millibars, 14,000 feet, the winds are out of the west-northwest at about 20 knots. And then as we get up to about 30,000 feet, 320 millibars, the winds are out of the west-southwest at about 30 knots. Now up to the north, where we have the stronger jet, the hodograph looks like this. There's Omaha. Looks like we got some bad data in there. Let me try another one. Let's try Denver. And there we go. There's Denver, showing weak winds near the ground, becoming southwesterly and just strengthening with height. And by the time we get up to about 30,000, 35,000 feet, the winds are out of the south-southwest at about 70, 80 knots. So remember, these are meters per second, and we double that to get knots. And that's going to be about, yeah, it's going to be about 70 or 80 knots there. And then just to give you a really weird wild card chart, let me get my cursor back. Hang on a second. There we go. If you just bang on your keyboard enough, you'll eventually unstick it. All right, yeah, let's try way up north. Let's try North Canada, Resolute Bay. That's way up there in the Arctic. Let's look at their hodograph. Looks like some poor chase potential up in that region. What we're looking for is kind of a hook shape there, because that would indicate that near the surface, winds are out of the east-southeast, and then they veer and strengthen, and then they become very strong out of the west, up in the upper troposphere. But we don't have that kind of pattern here. This is showing kind of a northeasterly flow. So it's kind of weak down at the surface, becomes east-southeasterly in the mid-levels, and then becomes strong southeasterly in the upper levels. And while we're at it, why don't we take a look at their sounding. Yep, still cold. Some may say that this is how Norman looked about a month ago, something like this. So very strong radiational inversion there. And you can see that we were below 0 Fahrenheit. Pretty good warming with height. Temperatures maybe around 20 degrees. Just off the surface, 20 degrees Fahrenheit. And then this looks more like a warm season SKU-T up in this region right here. And then here is the tropopause, and then above that the stratosphere. And here you can see those southeasterly winds there at Resolute Bay. And then we'll just do one more here. Let's try Belize. We'll try Belize City way down here. It's down in the Caribbean. We're expecting, the GFS keeps locking on to some sort of tropical cyclone development out there in about a week or two. So we might as well see what's going on. This is Belize, and up here you can see the ICAO MZ. That's indicating the Caribbean. Z is the country, that's Belize, and then the city and state, BZ. And looks like quite a bit of moisture. 70s dew points up to the lowest 2,000 feet or so, falling off to the 50s and 40s. And then once you get above 14,000 feet, looks like we pick up a lot of dry air. And that's probably due to subsidence underneath the subtropical ridge. Downward motion producing this subsidence inversion right there. So all kinds of neat detail, and I would definitely recommend going to University of Wyoming. There's the link there, weather.uwyo.edu. And this is a good way to practice. Just pull up different soundings and check them out. And you can also go to different locations around the globe. So we can even go to Antarctica. And there's a, let's just plot up one quick Antarctic sounding. There we go. Antarctica, they're slipping into the austral winter. You take May and add 6 months, and that's what things are like there. So right now it's like November 14th in the northern hemisphere. So it's starting to get pretty cold there. And we can see temperatures falling off there. There's the tropopause, but the winds are for the most part kind of light except near the surface. You can see a northeast flow there at about 20 or 30 knots. All right, so there's not too many YouTube channels that go over the Antarctic soundings. So hopefully that gives you something to look at there. Let's move on and take a look at the infrared imagery, and I'll get caught up on chat here. There's the infrared for earlier this evening. And oh yes, I'm looking at the graph. And I can see that I have not really bored anybody. When I start seeing that going down, I know people are checking out there. So I'm glad you all got something out of that. And let me get caught up on chat. I'm probably not going to be able to read all this. There's a whole lot of text content in here, which is fine. You know, feel free to talk back and forth. Sagan's Run asking about that storm brewing off the Mexican Gulf Coast. We'll look at that shortly. Willie Greenway asking about the outflow. Yeah, the outflow was those blue lines. That's correct. It's a very weak, kind of looks like the edge of a bubble that kind of blows outward from the storms on radar. And let me just scroll through here very quickly. Somebody getting a downpour, Mr. Manlet, out there in Illinois. Carl Berghoff supplying some good information there about the radar. Willie Greenway mentioning GR level 2 is expensive. Yeah, it's up there. I know there's alternatives out there. What's that program? It's an app, RadarScope. That's a good one. It basically gives you the equivalent of level 2 data, and you can't do quite as much analysis with RadarScope, but it is very useful, especially on a tablet. It's a great program to have. Maybe this week we'll go over a little bit of RadarScope. Irma, the most intense hurricane of 2017, Mr. Manlet, passing along that info. 914 millibars. Having some weird problems here with YouTube. I don't know if anybody any of you have this problem, I'm going through the chat here. Of course, now it's not doing it, but yeah, see that right there? It starts doing that a lot. It starts flashing, and then I lose my place, and I'm not too sure what's going on there. So just kind of bear with me as I kind of stumble through this. Jeff Krob went through Hurricane Frederick, 1970, 79. Yeah, and the year after that, we had Hurricane Allen down there in Texas. That was quite an unusual storm there. Pele just warming up. Thunder and lightning in Palatine, Illinois there. Okay, very good. Let's go ahead and head into some of the forecasts. Now we'll take a look out west. Looks pretty quiet out there right now, but I can see a little bit of, I think that's a little bit of instability there. This would be probably some debris cloud, maybe from some cold core convection. And most of what we're seeing here, all of this cloud here, this is a lot of stratocumulus. And we see a lot more of that as we get into summer. All right, so let me get this set up here. Let's take a look at the upper level pattern. And now we'll start looking at more of a forecast presentation. So starting out, there's our southwesterly flow there, polar front jet coming up from Arizona. We'll take this up to the current time. And there we go. Jet out to the west, and looks like we have some sort of disturbance off the West Florida coast. So there we go. That's some sort of, I'm not sure what the origin of that is, some sort of tropical disturbance out in that region. And then we've got this cutoff high up there in Washington. So conditions in that area probably very warm there in Seattle, and probably some fair skies in that region. The main polar front jet still way up to the north there. So rolling forward, looks like we come underneath some ridging tonight. So there's going to be some subsidence working on Kansas and Oklahoma. The next trough coming in from Arizona. So as we go through the day tomorrow, it looks like we're still going to be underneath that ridge, but that trough will be approaching from the west. And then by Wednesday, looks like we lose that trough. It kind of gets lost in this medium scale ridge right there. It'll probably reemerge on the other side, but let's check it out. And meanwhile, in California, cutoff low out there near where Mike R is. He'll be watching that there. Cutoff low moving out into Arizona. We've got ridging here on the plains, and the next big change will be the breakdown of that ridge as it moves east. That's going to be towards the weekend. And now we can see that across Arizona and New Mexico, the flow is really starting to pick up. Pretty good wave rounding the base of that trough. And it looks like starting around Friday is when things will get active on the plains. So by Saturday, come on. Oh, that's the end of the NEM. So that's as far as we'll go, but we're going to expect to see that trough moving out into the plains around Saturday and Sunday. I think I've got the European data up for that, so we'll take a look at that here shortly. So let's start out with the short term. Here's the high resolution rapid refresh. Looks like it's got fairly good initialization on these two clusters there. And then our frontal storms up there in Kansas also showing up. So the trend over the early evening has them dying out. And that's because of the lack of upper air support. Pretty much nothing going on there at 500 millibars. If we were under this flow here, there's a good chance that they would persist throughout much of the night. So these are going to kind of shut down, but we got to keep in mind that there are going to be some outflow boundaries kind of lurking through this area during the morning. So we got to watch that when things get going tomorrow. And then by dawn, we're looking at a pattern kind of like this. It appears maybe a quasi-stationary front in northern Oklahoma, across Amarillo and up towards Raton. And the dry line, of course, somewhere out around Midland. And then we get our warm-up. Looks like a little bit of a MCS, kind of a small MCS, elevated storms coming in from western Oklahoma. But for the rest of the picture, we're going to have to look at the NAM here. Central Plains, we'll check that out. Here's the upslope flow storms there in Nebraska and Colorado. And as we head into midnight, you can see that these manage to hang on. They're getting that upper level support. And we end up with a MCS across western Kansas. And that'll move towards the Wichita and Alva and Stillwater area tomorrow morning. And you can see that that kind of lays down a little bit of a meso high, and that'll kind of reinforce the broad scale ridge across Kansas and Oklahoma. And in turn, that means that that quasi-stationary boundary will probably continue to hang on there around the Interstate 40 area. All right, so that brings us to the NAM. So I'll have to load this up. All right, so let's see what's going to happen tomorrow. Okay, starting out around dawn, there we go. Not a whole lot going on. It looks like the NAM is a little bit less aggressive with that MCS there in Kansas. But as the afternoon goes on, looks like we got precip breaking out around the Lubbock and Midland area. We can see that inverted trough kind of in this region right here. See that little isobar right there, that 1012 isobar? It's forming that upside down V, and that indicates that that's probably where that front is located. And then down to the south, that's our dry line. So it appears that these are triple point storms and dry line storms. And let's take a look at a forecast sounding for 21Z. We'll pull that up around Snyder or Post. See how things look there. And let me get a drink here. Wow, very steep lapse rate. It's very impressive there. I'm sure the vertical totals are very high there. Do we have vertical totals on here? Let me check. Nope. No, there's no measure of it. We would have to go by this lapse rate thing right there. And let's see here. 8.1 Celsius per kilometer. Yeah, that's pretty steep there. And it looks like our moisture thickens up a little bit. It looks like about 130 millibars of moisture. And let me show you a good way of tracking the depth of this moisture. Now, usually when we talk about moisture quality, what we're looking at is dew point. So we look at these dew point charts here, and we see that maybe 60s and 70s are coming up northward, and we make our forecast based on that. But another method that we look at is the 850 and 925 millibar dew point. And this product is kind of hard to find. You don't, as far as I know, only Pivotal Weather and I think UCAR, only they have this. Typically what you'll get is relative humidity. You don't want to use relative humidity to calculate buoyancy. So let me pull these products up and we'll take a look at them. So 850 millibars. We're looking at the dew point up at about 5,000 feet. And we can see that the moisture quality is actually pretty decent. From about San Angelo to Abilene to Altus, north central Oklahoma. And this is important because our radiosonde stations are over here. And a lot of times they don't sample this moisture. It goes in between the sites. This is a classic example of where we need more radiosondes out there, and I don't know how there doesn't seem to be the political will for that to happen, and I don't think anybody in the Weather Service is advocating for that, especially at least anybody high up. So I don't know. We could really use a site there around Abilene, or maybe another one at Victoria, and that would help better sample and capture this moisture that goes in between the sites. And the only reason the rapid refresh even picks up on this is because of alternate data sources like satellite information, but also first guess fields from previous runs. There's a very, very sophisticated analysis system. It's called the Global Data Assimilation System. And they pull in data from all kinds of sources, and that's how they're able to kind of fill that in. And I'm really amazed that it works the way it does. But anyway, it is there. We can see that by 12Z, 850 millibar moisture is going to be looking like this. So it is going to be probably in between the radiosonde sites. And then by evening, you can see that a lot of the deeper moisture is right around the Abilene area. And we can see that there is some convergence of the 850 millibar wind field. So very likely we have a little bit of forcing taking place there, maybe some thermal troughing in southeastern New Mexico, and that's helping to back these winds there in along the caprock. And we can also look at the 925 millibar dew point. This is up at about 3,000 feet. And it gives kind of a similar presentation there. So by 21Z, we can see that the best moisture is right in there. And this is good because we can actually pick out the moisture axis and look at that on the forecast sounding. So there you go. That's about as good as the moisture is going to get. Looking at about, I'm reading it off the top of these green lines. That's about 14 grams per kilogram there for our mixed parcel. So we definitely got some instability there. The cap is just weak enough, I think, to get storms going. So this is probably a fairly decent chase day. It doesn't look like a whole lot of severe weather due to the weak wind flow. Well, I don't know. Our hodograph is stretching out a little bit. And we can see the winds there are backed at that spot that I picked. That spot that I clicked is right around Guthrie, Knox City. Yeah, somewhere in that area in between Childress and Abilene. So it appears we may have kind of like a locally favored area right in that region. You can see a little bit of SRH in that area, some very weak 0 through 1 kilometer shear. So this is going to come down, I think, to mesoscale accidents where we have the best chance of tornado development, if we even get tornadoes. But I think the best place to start out, just looking at all this data, is somewhere probably right around Guthrie to Plainview, along the caprock. Probably a good day to head out towards Turkey or Quitiquay and check out some of the scenery there on the caprock. Okay, let's take a look at the longer term. I think I got kind of off track here. Okay, there we go. Yeah, let's look at the next day. Let's look at Wednesday. Starting out, looks like a little bit of low pressure around the Fort Worth area, high pressure up to the north. See, I'm showing you how I'm reading these charts. I can see high pressure there in Wisconsin, in Michigan. So this is all kind of a cool air mass up in this region. And then we have our low pressure right there. So possibly we might have some sort of boundary, maybe coupled with outflow. possibly even further north. Looks like it'll be somewhere in the Red River or around Interstate 20 like it's showing. And then as we get heating going on, looks like very weak pressure gradient. Probably some of the better dynamics are going to be out west. And then by 18Z, pressure falls out west. Looks like high pressure there in Kansas. And then towards evening, storms going up along the Caprock around Snyder and Post, and just east of Lubbock there. And then a few more further up towards Canadian and Guyman. So that's not great, but at least it's something. And then we see another Canadian air mass making its move into the Dakotas, and looks like another repeat of convection for Thursday along the Caprock. So probably a good time to get a hotel room there at Childress or Plainview or Snyder, and hope to capture something. Now let's look at the more extended picture. As we go forward, we can kind of maybe look at what the GFS is showing for the next few days. Tuesday evening, it's going with convection there around the Childress area. Not so much south along the dry line. Oh yeah, there goes something. Just after 0Z around Childress. So yeah, the GFS pretty bullish with that. A little bit of a MCS moving south towards the big country of Texas. And then for Wednesday, looks a little bit more quiet. And I can see maybe some sort of boundary right there. That's probably partly outflow from that MCS that tracked from Childress to around Stephenville there. So that could be an important boundary there for Thursday. Pressure gradient picks up. Quite a bit of cold air up to the north. And let's try to find our next big weather change. We can see a lot of the effects of a lot of heating and some lee-side troughing there in Colorado. So it stays kind of cyclonic out in that area. So we've got kind of a mean configuration like that. Plains breaking up southerly flow with that low pressure there in Colorado. Anyway, it does look like things organize as this Canadian system comes out towards Friday. And then for Friday proper, let's see what's going on. Yeah, big, strong cold front coming into Colorado. And this might be kind of a stationary front there in Nebraska. So there's actually a couple of possible plays. One is the upslope right there in Colorado. The other is the intersection of the moisture feed with the front. And that would be south central Nebraska right there. So we're talking about Friday here. And we're going to compare this with the European model. So here's that big high driving that. Okay, then for Saturday, looks like MCS is overnight through Nebraska, maybe even in Colorado. That's kind of unusual. Looks like that front sinks southward. And the model is not too aggressive with any development along that front. So it looks like it could be either along the front there, Wichita to Enid, or maybe along the warm front around Kansas City to Bethany. So this is a pretty fresh outbreak of cold air, and it's probably going to undercut stuff, especially along that cold front. So that's one thing to keep in mind. And there is going to be a dry line out there, but we would have to look at the dew point products. And why don't we do that just real quick? Saturday evening, let's look at the dew points and find where that dry line is. Okay, here we go. Okay, so this is for Saturday evening. Yeah, this is the very same time. So there's that front coming out of Kansas. There's that warm front. You can see how much better the moisture is out there in proximity to that warm front. And down in Oklahoma and Texas, it actually looks like that dry line is around maybe Alva down to Lawton, and then down to about maybe around, let's see, around Ballinger, and down to Junction. And we can see that west of that boundary, dew points are in the 50s. And that's not going to support very much severe weather. We want to be on the east side of that boundary there. So we can take that information and go back to the other chart and do our forecast for Saturday. So we put that information on there, and that gives us the dry line position. And the model is not breaking out anything along that boundary. And why is that? Well, we can pull up the forecast soundings. We got to be careful to get ahead of that dry line. Maybe let's try around Wichita Falls. Again, we're looking at Saturday here. And it looks like our problem is maybe the moisture depth. Pretty strong tapering of that moisture with height. And there is some capping there, but it's not particularly strong. Moisture profile, or I'm sorry, the wind profile, not looking too bad. And then we can also look at the the significant tornado parameter. This is the dump of all the weighting factors, and we can see that the main contributor here is Cape. So it's showing that the Cape looks good, but everything else is not so great. Marginal SRH, poor bulk wind difference, and so on. Now we do have some decent 0th or 1 kilometer shear here, but SRH, that is pretty iffy there. Then that brings us into Sunday. Starting out, looks like maybe an MCS in western Oklahoma there. Looks like that front pushing southward into the West Texas area. Then by evening, it's hard to tell where that front is, but it looks like something like that right there. And the storms tend to favor West Texas. Yeah, they're there, going up in that region right there, and nothing for North Texas. And then just going quickly through the rest of the data before we move over to the European. Looks like high plain storms for next week. Tuesday, Central Plains as another front comes southward. And then for Wednesday, same deal. Another front up there along Interstate 70. Bit of an MCS overnight. Thursday, things shift eastward. I should do forward forecasts. That would be kind of interesting, kind of a unique viral website maybe. Forward chase forecasts. I don't know, somebody else can try doing that there. But anyway, yeah, here's that next system that heads eastward for Saturday the 26th. Kind of a weak high pushing south. And looks like some severe weather potential maybe for Saturday and Sunday that weekend. But overall, I don't see anything that looks really organized. There's certainly no big Pacific systems coming out of the southwestern U.S. And then down to the south, we see that tropical system that the GFS has been trying to pick up on. That's off to the bottom of the screen. And I saw that the earlier runs, I think the earlier GFS runs were bringing that up towards Florida around the 26th, 27th, but it looks like it's flip-flopped on that once again. And let's go over to that European model. And I would like to thank the people at EuroWX for clearing this. Now, we can't look at all the frames in here because a lot of it still is restricted, but some of the derived products on here, those I can show you, and that should give us just enough information to help fill in some of these blanks. So let's try giving this a shot. We're looking at here at pressure, and looks like the wind flow and precipitation. So we'll just do a quick look at this. Saturday, hang on a second, I'm out of sequence here. Okay, so there's the current product. So we can see that little area of storms there in around Abilene. And I'm just going to go ahead and run this forward and show you what things look like at peak heating. MCS goes through. Okay, yeah, I'm sorry. Tomorrow morning, European really going strong on that MCS. Let me run this back and you can see that. See how that develops there in Kansas around midnight. I don't think the GFS was quite that strong, or even the NAM with that area, but that really comes together. It looks like it's being fed by some good moisture and 850 flow, and that goes south in Oklahoma and possibly reaching Dallas there. But I'm sure that MCS will be dying off around midday. I don't know. European model wants to keep that even at peak heating time. This may be actually new convection developing with those boundaries down to the south. But anyway, by 0Z tomorrow evening, it appears west and southwest of Fort Worth, according to the European model. Then for Wednesday, peak heating looks quieter, and that's what the GFS did show. I'm sorry, the NAM showed things to be quieter on Wednesday. Just a little bit of high plains convection. Then for Thursday, looking at maybe western Kansas there. And then, of course, things shift further north with that new frontal system. Looks like it's going for some storms there on Friday in North Kansas. And what you want to do with this kind of model at data is you want to kind of classify what type of target you're looking at. Like, is that a dry line? Is that a warm front? Is that upslope? And that'll help you kind of that'll help give you an idea what you're looking at. And the other possibilities, it could be an old MCS from like the previous night. So what are we looking at here? Well, to answer that question, we've got to kind of figure out where the fronts are. And I think we're looking at something like that. I think this could be a warm front situation, because I can see a couple of thickness lines right there. So I think we've actually got a warm front. All right, so this could have some severe weather potential Friday, north central Kansas, warm front situation there. And then up to the north there in Nebraska, that's probably going to be kind of a cool pattern there. Looks like a lot of cold north wind. Then going into Saturday, this looks like a lot of anafront type showers. Keep in mind that this is not like severe thunderstorms or anything like that. This is where the heaviest rainfall is. It's showing the precipitation totals there. So it looks like kind of showery post-frontal precipitation, and probably not much along the boundaries themselves, mostly in West Texas there for Saturday. Then for Sunday, looks like West Texas once again. I think there may be kind of a weak front in this region right here. We can see the wind flow converging. So I wouldn't rule out maybe some convection there along the Red River. And let's go into next week. I know we're kind of dragging on. Oh, my. It's after 9. I'm sorry, guys. I know some of you are hanging on here. I appreciate that. All right, so, yeah, we get back into the southerly flow. Let's look for the next big change. Looks like a warm front activity up there in the northern plains. And next big change, that's it right there. Yeah, that's the last frame there, 240 hours. And that's all I got here. Actually, no, I've got one other thing here. I've got some of the upper level data. Vorticity, that's a derived product, so I believe I'm allowed to show that. So let's look at that. And this will give us the contribution of the upper level pattern to the severe weather. Let me get this started. And there's the current pattern right there. So ridging for tomorrow, but we do get convection going up. This is the peak heating time, and then things shut down for Wednesday, and I'm wondering if that's due to the conditions aloft. And yeah, very broad ridging there. I think that, plus we can see a lot of white there indicating anticyclonic vorticity. We're probably seeing a lot of subsidence working across the area. Looks like the ridging could be a problem through Thursday, and then we start breaking that down a little bit. We start seeing some troughs embedded in the flow start to affect the area by Friday. So we're definitely getting help from the upper levels, maybe starting late Thursday, going into Friday. And this is about what I like to see on a severe weather day. Some help from aloft, but not like an overwhelming big dynamics like what you see there in California. So the next big change, it's going to be the breakdown of the ridge around midweek according to the European model, and then we'll start seeing the approach of that system there from the four corners. So maybe another round of severe weather coming up for the 23rd through the 25th and 26th. And then after that, we'll just have to see. Okay, let's look at the graph and see how many people I put to sleep. Whoa. Okay. Good to see that. I appreciate y'all hanging on there. That's a little bit of a morale boost. Let me look at the chat real quick and just kind of scroll through here. Jeff Krob says the Weather Service is relying on satellite sounding to fill the gaps. But what I'm wondering is how are they getting the humidity values? Somehow it's filling in the dimensions and the amplitude, I guess, of the moisture field there. Not only in between the radiosonde sites, but due to the southerly flow, a lot of that's originating from Mexico, where there's not much data. So I'm kind of curious, are they able to get moisture data? I don't think they can, but maybe there's something I don't know there. So, yeah, I'm not too sure about that. But Jeff Krob, maybe you know. I'd be curious to find out. Best weather, planes dump a lot of CO2. Yeah, that's true. Undertaker for president. Special hurricane coverage was great last year with Harvey. Does this qualify as death ridge? No, I wouldn't call it that. I was around for the 1988 chase season. I wasn't quite chasing back then, but 88, that was a death ridge. We were pretty much shut down. That was a really bad year. But, you know, we are getting some storms. The pattern is slowly coming together, and we can't totally write things off until we get to, say, June 5th, June 6th. Once it gets up to that point, if it's still looking like this, then yeah, we would just have to throw in the towel on that. Anyway, that's probably going to do it for me. And just as a reminder, if we have a moderate risk coming up and my schedule is free, I will open the live stream and we'll do some chart analysis and kind of go over mesoanalysis. And I'll try to turn to some of the classics, like there's been some really good stuff published in the 80s that I can show you, and we'll go over some of those journal papers and try to apply that. So again, that's going to depend on my time and what's going on exactly. But we're going to need a little bit more activity than what we had today before I'm able to really cast aside my work and show you guys that stuff. But we will have one of those days coming up in the near future, maybe in the next week or two. And hopefully that pans out there. All right, so that'll do it for me. I appreciate you watching the webcast. Is my music going? Hang on a second. Having some weird problems here. My music keeps starting and stopping. Well, I could just ignore the music, but I want to close on a positive note. Okay, we will run VLC. And this is a great program. I don't know how many of you watch a lot of video in audio. VLC is a great program, and it will play anything. And I'm sure it will get our music going here. So let me pull that up. And then once we do that, we can go out on a proper note here. Okay, closing song. Yeah, I've got a bunch of different versions of my song here. I don't know if y'all can see that, but I'm going to try one of these random ones. Y'all don't hear these very often, but we'll give it a shot and see what it sounds like. All right, so that'll do it for me. I appreciate y'all joining the webcast. And I don't know if that's playing, but anyway, I will let you guys go. I've been messing around with this too long. Anyway, thanks for joining the webcast. We'll see you all tomorrow. Take care. Bye-bye.